This is Universal Gravitational Constant, presented by James Whiteside, Clinton Flores, Matthew Ackerman, and Amanda English. Universal Gravitational Constant, often known as the letter G, uppercase G, is a fundamental constant in physics. It is the strength of gravity between two masses, and it appears in Newton's law of universal gravitation. G is one of the least precisely known constants in physics due to its experimental challenges. It also helps us explore gravitational interactions. And this is the formula for universal gravitational constant.
Hello, my name is Clinton Flores, and we will be going over relevant fields regarding the universal gravitational constant. The first one is astronomy. It helps calculate the gravitational forces that keep the orbits of planets, moons, and satellites. Helps with mass estimation. To find the gravity, you need to know the mass. It helps give accurate predictions of positions and movements over time. This is a picture of a galaxy, which goes along with the orbits of planets, moons, and satellites, as that is what's found in galaxies and solar systems. The next field is engineering. Aerospace engineering is used for calculating satellite trajectories, orbits, and space travel dynamics. Places like NASA, SpaceX use this to calculate their satellite orbits and trajectories. Launch and re-entry dynamics. It helps figure out how you're going to get this big rocket ship up into space or back home from space. Civil engineering. It is rare but can be used for large-scale earthworks or gravitational foundations. It is useful in large projects like tunnels, bridges, or oil exploration. Also useful in construction of dams and things, large-scale earthworks. As pictured here, this is massive bridge construction.
Okay, so I'm going to pick up and continue on with relevant fields and talk about geophysics, which is the science of studying the earth, hence geo, using physics. So instead of using a shovel to dig into the earth, scientists use calculations and formulas to discover and identify what's under the earth's surface, such as in its layers, mantle, even down to its core. They also use G to learn how heavy the earth is and also how each of its layers are made. We're going to go back to that slide, actually, sorry. So this is where it talks about geophysics. It also monitors changes in the environment and helps model planetary bodies. And so that kind of ties in with our next slide because we go into scientists that were relevant during these times, and the first one that I'm going to talk about is Isaac Newton. He was an English mathematician. He was also a physicist, and he was also an astronomer, so he knew a lot about a lot. And he's most known for formulating the three laws of motion, which form the foundation of classical mechanics. He also discovered the law of universal gravitation, which states that every mass attracts every other mass in the universe. And so that is wild, but it's very neat. And so he also wrote a book that is called Principia Mathematica, and it explains gravity and motion using mathematics. And so he's known for basically laying a lot of the groundwork for modern physics and discovering about how objects move on Earth and in space. So his love for those two ended up finding a lot of information for modern physicists to use today. Sorry. And then the next scientist I'm going to talk about, and this is him at the top. And then the next scientist is Henry Cavendish. This man was he was more like reclusive. He was not a social butterfly. He was a British scientist, and he liked to experiment with physics. And so he's most known for measuring the force of gravity between masses using a device called torsion balance. And in his experiment, which they later deemed the Cavendish experiment, allowed him to calculate the value of the gravitational constant and estimate the mass of density on Earth for the very first time. He was, like I said, he was quiet and he was reclusive, but his accuracy with just his experiments were way ahead of their time. They were also extremely accurate.
Scientists continued. Albert Einstein developed the theory of general relativity, which redefined gravity as the curvature of spacetime. Robert Hooke proposed early ideas about gravitational attraction and its relationship to distance. Scientists continued. Ernest Mach influenced the understanding of gravity through his work on inertial frames and the Mach principle. John Archibald Wheeler contributed to modern gravitational theory and the concept of black holes, enhancing our understanding of gravity's effects.